and I will talk about flight safety concerning electric gliders. And as we do not have that much experience, I will start to talk about the only experience I have from accidents and incidents in Sweden, and then add some more accidents in this area for your consideration about this. And our first experience about an accident with the electric glider was with the Silent 2 ultralight glider. It was an accident during launch, and it's a pity that we have that kind of experience, of course. We need to learn more, but what we could learn from this accident was first of all that the battery was not fully charged. So the flight started with roughly 78% capacity, and we also identified that we have low temperature involved, giving us an outcome with voltage drop and lower RPMs. And when this happened, we could see also that the pilot got some warning low voltage reduced power, which we have seen that is built into this management system. And what we also could see was a situation where the glider accelerated very, very poor and had a very bad climb performance. And the glider then climbed out with very low speed, close to stall speed, and then at low altitude had a stall spin situation and crashed into the ground. And the pilot survived but got quite substantial injuries. We did some internal investigation on this, but as an ultralight, it was not a formal accident investigation. So we only did an internal investigation. And one interesting part in this was that we had, in fact, the day before this accident, an ordinary launch with fully charged batteries, and we could therefore compare the launches with this launch. So the first day before this accident, we had a normal launch with full throttle with really good climb performance. But during the actual day with the accident, we could see that it was really poor, and we could also see that the glider had not fully charged batteries, and we could also see that the glider was in a hangar during the night where it was quite low temperatures. We think it was even below 0 degrees. But the battery pack during the start was recorded at 13 degrees of temperature. And what we also could see was this warning information, and we then assumed that the pilot got this warning almost immediately when starting, and could perhaps then take the decision to reduce the power, and then had this very, very slow acceleration. And what we could see was, when we took all the information out from the glider, we could see that it could be this, but the pilot could not remember anything from the launch during this flight. So what we could see was that we had this voltage drop, and we had during the launch only 9 kilowatts of power. The maximum is 22 kilowatts. And we have yesterday talked about that you can go into soaring mode when you're airborne, flying with 6-7 kilowatts, and here they made a launch from the ground with roughly 9 kilowatts. So with this, we could barely see that we could have a climb performance of half a meter per second.
Can I ask a question? Was when the pilot got the warning message in the display during the takeoff run, was it voluntarily that the pilot chose to reduce the throttle, or did the system do this automatically?
No,
you could have disregarded it. Right.
Yeah, okay. I will come to that.
Okay.
So this is something we assume that it could be the case due to the.
We can't remember anything.
Yeah, I know.
And therefore, also I think it's important to have in your mindset about to abort the takeoff. So if you don't have a proper acceleration, you must understand that. So when we talk about abort takeoff, we normally decide to have some abort point. But I also think it's very important when we talk about self-launching gliders that we also take into account acceleration. So if you don't have enough acceleration, you must realize that there is something wrong. And some of you may remember we had an accident in the northern part of Sweden a couple of years ago with the Ventus 2, where the ground roll was roughly 1,000 meters before the glider got into the air. And when I talked to that pilot, we discussed it. Didn't you have any idea about the acceleration? No, he said. But I mean, if you're 1,000 meters before going into the air, you must realize that there was something wrong. But he had not trained in that way. So therefore I think that is a good experience to take with us. And what we did was we tried to collect some data and compared with an ordinary launch with the Silent 2. And here you can see the red compared to the green, which is time after takeoff, and the height the glider reached. And this is a much more normal climb profile than you can see here. And we can also look on the power setting, how many kilowatts that was using, and we could see that an ordinary launch, you had the initial takeoff, quite a lot of power, and in this case it was a launch in fact here at Ålleberg. So after takeoff the glider pilot used the ridge here and reduced the power. But in this case you can see the launch during the accident, we can see a drop quite quickly. And we could also see when measuring the battery voltage, we could also see that the initial phase of the launch, the battery voltage dropped very quickly, or it even, as you can see, started at a very low level. And here the red, the black line here is the low volt warning level. So probably direct after giving full power, the low volt warning came. And we then assumed that the pilot then manually reduced the power, and then the warning disappeared. And then you could also see that we have an increase of voltage. And the green you can see is the same when you reduce power, the voltage increase here also. And what we did with this information was that after the accident we investigated a little bit about the battery packs, how they, if we discharge them and if we do that in lower temperature. And we could very clearly see that we have a voltage drop which is increasing if you are at the lower temperatures. We even tested the battery packs at 1 degree and we could see a very rapid drop of voltage. And we also tested to check if we only have roughly between 60 and 80% in the batteries at this temperature, and then it dropped down to the low voltage level where you get this warning immediately. That is quite interesting. And with this information, you can imagine if you have a pilot buying your own glider with no formal training, more than reading the manual yourself, and then start to fly and have these issues. But if you go and look into the manual, there are a lot of information about you need to have the battery packs fully charged, always self-launch with freshly charged batteries, and also never self-launch when the battery temperature is very low, because you also have a low temperature warning. And then also you have in the flight manual that you should always respond to any warning that if you have the and there's a situation where you need to really use the power in the engine, you then decide to use that. So it's important to understand that. And when we looked into this, we could see all these levels of warnings and the information the pilot got. And of course, even you can read about that it's clearly, if you have a dangerous situation, you must decide yourself to continue, to reset this warning. So I think this is quite good information for us that we need to understand this. And especially in the Nordic countries where we have these cold temperatures, we can have a situation where the battery packs are cold and then we don't get all that power. So I think that is a good lesson. So this is what we then collected, of course. I will not go into that deeper, but I will add a couple of other interesting accident with Silent 2. We had last year in the UK a accident that is, well, it's a similar profile. You have a takeoff and an accident immediately after takeoff. But this accident, it was a situation where the propeller hit the ground and the glider then climbed very steeply and more or less flew into a stall incipient spin and then crashed. And during this investigation, I was in contact. They contacted me about this accident in Sweden, and we talked about climbing performance and how to fly these kind of gliders. So what we could see here was also what they were looking into about always self-launch with pressure charged batteries. And they could also see in this case that the pilot normally used winch launch, or because he would like to preserve the battery for if needed during cross country. And we could also see that you need to be aware of these things. And also one important thing that I also had in my mind in our accident in Sweden is about how the human being is into the technology, and where we can see in a scenario during a ground roll, if you have a bumpy airfield and it's happening something and it's hard to see what is the next step to do. And about to use these new technologies where you have these rotary throttle control knobs, and it can be hard to find it and to use it. And as we heard earlier, to have a lever, perhaps it's more close to what we are familiar with. So I think this is also something that could be very important for us to understand. And for us who is flying these gliders, I think also that we need to think about this in certain situations where we need to understand it fully. The BGA, British Gliding Association, they have also published a safety briefing regarding especially this accident also, where we can see when we are flying these ultralight gliders with very light stick forces combined with high levels of friction, that you don't really have this good feedback. And also about the center of gravity, that you should be aware of not to have the center of gravity way too back, because you have, with this climb performance, the nose will go up quite easily. So it can help to fly into a situation where when you lose control or something, that you enter a stall situation. So they're also giving guidance of using lower flap settings. And here they are also recommend to think about the procedure for aborted takeoff, which I think also, when it was in our case in Sweden, very important. And they also refer to other accidents, and here they also refer to the accident we have in Sweden, where we can see the similarity that you have a situation during the launch, you get airborne, something ends up with a stall spin situation. And now we also have an accident in Switzerland, but it seems to be some stall situation during ridge soaring. So this is the regarding launches. Then we also have other spectacular accidents. This is an accident with a Silent II in US, and I have not found so much information about it, more than the pilot thought he had some 20 minutes of power left and was on final approach to his airport, and then suddenly he ran out of power, and he had a forced landing on a roof. He survived, but in this case in the US, to crash into something that can be a very big issue. So this is something we need to also learn about when we are flying these electric gliders, so we do not end up like this. The last consideration I would like to say is about safety of battery and fire. And this was an accident with the Pipistrel Taurus, and it suffered an in-flight fire in the battery compartment. And what is really interesting here is more like to see, we heard about it here also, about how we take care of the battery packs if we sort of have some problem with, we are dropping them in the ground and so on, and also how to charge the batteries. And here we could see that they had in some degree had some accident with the battery pack, and also that the pilot didn't follow the manufacturer's recommendation to charge the batteries. So during flight it was an in-flight situation with a fire, and the pilot then tried to immediately return for landing, but it went very fast, everything, so the fire spread, and the glider was in high-speed descent, so it seems the wing failed due to structural overload. I guess the pilot decided to get down very, very fast. So that is
and it has low V&E also, the towers,
of course.
And the flap settings can be easily overspeeded.
Yeah. And another accident when we have about fire, it's also about conclusions about dropping the batteries on ground and something is happening, and also there are some safety considerations about what you can do if you have this problem in flight. And the last comment here is more or less that the only way you can get out of the situation is living with parachute, more or less. So I think these are some considerations I think at this stage we can take with us. But we do not have that much information. We don't have that much facts that we can use today, but I think we have some, and the first ones we have are of course microlight gliders, and I think also when we talk about certified gliders, EASA certified gliders, then we look into all the safety issues, which I think is very important, and I think we all need to inform our members when they're buying gliders that they need to think about all these features, so we don't end up with a lot of new accidents. So I think it's very important, and I hope the industry continue to work with all this in mind. Okay, That was
Okay.
quick summary questions.
I can just emphasize what Henrik said about this, that I think we will see electric riders coming in. And then it's a new approach to it in the clubs. I mean, in the clubs we are used to batteries, but we can't handle the glider batteries for engines like we do with the avionic batteries. We have to have a new thinking of that. And I can give you a funny example of this. When we introduced the HK21MI in our club, self-launcher, it was new for all club members. And we said that now we must remember, before we take off or taxi out, we have to say on the radio that the hotel take because we don't use that. That's the job of the type pilot. But now we have a type pilot. And everybody agreed. And then one of the first flight I flew with Göran Ax. At that time it was the chief flying instructor on the Boeing 767s in Scandinavian Airlines, world champion in gliding, and he took off without talking on the radio.
Okay.
So it's a new approach for all of us.
Yeah. Okay, very good. Thank you. Then we plan for leaving for flying. Same procedures as yesterday, more or less. I guess we will have the same launch point as yesterday. So we will now move away so you can fix your lunch.
Who will fly the gliders down?
I think we have the 3 first people will do the ferry flight down, and then we continue according to this list here. Okay? Okay. Thank you very much. Reminder, room keys also.
Jeg begynder nok stille og roligt køre mod København. Jeg tror, det er flyvende i år. Jeg tror, at vi kan gøre igen.